So hello friend, in the last video we have learned about how to handle data in R and the changes in the data. For example, some addition in data. If you want to add certain variable, if you want to delete certain variable, if you want to change some specific variable name, case sensitive, say capital G, capital S. So we have learned about all types of command. So in today's class, you can use R as a basic calculation. For example, in your calculator, you do basic calculation of plus minus. So in R also you can do the same. Let's open the R. So here I just type x equal to 12 and y equal to 15. So z equal to x plus y. What is the value of z? Let's run it. So you can see that the value of z is 27. Let me let me highlight my cursor so that you can easily see my movement of cursor and command. So here you can see that the plus command is executed. So if you want to say x plus 8, so it is 20, that is 12 plus 8. So if you want to x minus 8, so it is 4. Likewise, you can do multiplication x multiply by 12, 144, y multiplication by 12, so it is 180. So same wise, if you want to square root, s q part is square root of, likewise you have many command, square root, log 10, square root of say y. So this is the square root of y. If you want to log, here is log of x, so that is 2.48. If you want to log 10 of y, so that is 1.17. Like if you want to have sine theta, cos theta, sine of x, let's run the command, that is 0.04. So these are the basic calculation. You can do these basic calculation in R. So let's go to today topic. So today we learn about the basic calculation in R. So the basic calculation are some descriptive statistics. For example, you have collected the data from the respondent, and now you have done the basic collection, basic uh, calculation for your data. So basically, when you collect the data from the respondent, you do some basic analysis. You learn what type of data you have so that you can apply certain statistical test in the later stage. So some of the basic tool for the description of your data, that is mean, median, mode, then you have minimum and maximum, then you have quartile, first, second, third, fourth, that is 25, 50, 75, and 100%. Then you have standard deviation, variance, that is the square root of this, then skewness and kurtosis likewise. So basically, before running some basic statistics, you have to understand that when we generate some basic statistic from the collective data, that is mean, median, mode. So basically, we divide the data mm, into some categories, or you can say that the level of measurement can be. So there are two basically distinction, that is continuous or categorical variable. So your data may be continuous or may be categorical. So what is continuous data? So continuous data, that is as such data which are continue in nature, that there is no break in between the data. For example, you have collected the height of the respondent, so you have seven respondent, so you have all the height, you have the height of respondent, you have the weight, you have the weight of different weight of the respondent, or you have the bp blood pressure calculation of the respondent. So there is no breakage in the data, it is a continue in nature. And once such data you can use the mean and median. Second is categorical data. Categorical data, basically you divide the data, so there is no particular order that your data must be in a particular order. Say for example, you have gender, that is male and female, so you can take your categorical data, like you have used, first you use female, then you use male. For example, yes and no, rural and urban, literate and illiterate. So there is no so basically you have two categories there, and there is no order. You can first use illiterate or then literate. You can first use illiterate and then literate. So there is no order. So this type of data is categorical data. So we can use mode in this type of data. Whenever you collect the data, so based upon your data variable, it is continuous or categorical. Your test vary in the later stage, that you have to use particular type of test for particular type of data. So let's go to R. Let's clean this first. And so I have write all your command here, so that our time will save. So let's change my window so that you can easily see my screen. So here you can see that this is my data, that is the age, and less than sign dash C means combined, like in the previous video you have learned. So these are the ages, these are the weight, height, and these are the BMI. This is the command data dot frame for age, weight, and height, and BMI calculation. So let's run the command. Well, so here you can see that we have run the command, and this is the BMI score, that is age, weight, and height. So likewise, I have shown you in the PPT. So I use this hashtag. So this hashtag is just for your understanding that what type of command we are using. This is not a command. So basically these are the command we will use here. So basically if you want to apply mean for the particular data, so you have to type mean and then in the bracket, that is age. Let's run the command mean. So here you can see that mean of age is 49. So what is the median? So median of age is 50. What is the maximum? So maximum is 64 for the age. And what is the minimum? Minimum is 35. So if we type range of age, so the range is 35 and 64, minimum and maximum. Then you have quartile. So let's run quartile of age. So this is the quartile of age, that is 0%, 35, 25%, 40, 50%, 50, 75%, 56, and 100% 64. For standard deviation, you can write ST of age. You can run the command. So standard deviation is 11.31. And for variance, that is the square root of this standard deviation of age, you can run. So the variance of age is 25. So likewise, you can calculate the basic mean median mode of your data. And likewise, you have the command, you can add here command summary, and in between you have to type BMI. So here also you can get the calculation of age, weight, and height. So this is my variable BMI variable. Here you can see that BMI, there are 6 observation and 3 variable. So you get a combine of minimum, age of minimum, maximum, medium, and maximum mode. For weight and height also you have got a combined score. Likewise, the next command is movements. In the earlier video, I have shown you how to install the library. So you can go to tools, install packages, type here MOM. So here it is movement. So you can install. So I already installed it. Let's cancel this. Or then here you can type the command library, then movements, then your movements package will activate, and now you can run skewness of height. Let's run. So the skewness is minus 0.77. Same for cortices in bracket, in between bracket height. So the cortices height is 2.64. So these are the some basic descriptive statistics for the above data. Now we have some other commands. So here you can, I have highlight with the hashtag. If you want row wise sum up of data frame using apply function in the R. So there are some function, you can say that these are the family of apply. So with this command, so for in apply command you will get row wise sum of the data frame. For example, the command is apply, in between bracket BMI is our data frame, comma, then you have one for row, comma, and sum. Let's run the command. Let's see. So here you can see that our data are row wise. So here you can get the row wise sum. So these are my the data. These are my data. Likewise, you have, if you want column wise sum of data frame, you write the command apply BMI, comma, 2, comma, sum. In the previous video, I told you that one is for row and second is for column. So if you type any command in the first bracket, one is for row, and after that it is for column. So two for column wise. So let's run the command. So here column wise breakup of data frame, that is age, weight, and height. So it will give you the sum. Sum means addition of all the variables. So if you want column wise mean of data frame, so this is the sum. And if you want mean, so the same command apply in between bracket BMI, comma 2 for column, comma and mean wise. Let's run the command. So here you can see that it is mean wise. So age mean is 49 and weight 68.16 and likewise height 172.50. So this is apply command. Another you have s apply command. So s apply command, whenever you want your data in the column wise only. So there is specific command s apply. This s apply will do the calculation column wise, always in column wise. So s apply, you write BMI and mean, it automatically apply column wise. Run the command. Here you can see that age, weight and height BMI on the basis of column wise. So this, if you apply s command, s apply, you do not need to add the numbers. It directly means it is column wise. Next, we apply t command. So it is also a apply family command. It is t command. T apply function with r. It is for the bifurcation, dividing of descriptive statistic according to category. So for this, our command is t apply, that is height our variable, gender and mean. So here you can see that height and weight is there. So let's introduce a new variable, that is gender. We can copy paste this. So gender is included in your data frame, and let's run the whole command again, run. So it is added. So here it's our command, that is t apply. T apply for height, for gender and for mean. So let's try the command. So that is t apply. So that is, you divide the data on the basis of female and male. So on the basis of height, on the basis of gender, you divide the data. So you get the data that these are the female, this is a mean, and these are the mean of male. So the next command is calculation of aggregate mean of height by gender. For example, if you want the aggregate of height in gender basis and for mean. So the command is aggregate, and in between you have to type height, and this is tilt sign. You can get this tilt sign in your keyboard at the top left corner before the one key. You have tilt sign. So this is a tilt sign, gender basis, comma fun equal to mean. So this is the command for aggregate. Run this command. So here you will get the aggregate of gender, height, female aggregate, and then male aggregate, male wise. Likewise, there are many other commands for descriptive statistics. So let's use some additional variable. So here I have added ID. These are the 8 respondent. These are gender. These are age, weight, height. We have added cholesterol and then income of the respondent. And again, we have added a new data, that is social data. The command is data.frame, and that is combine all the variable, that is id, gender, age, weight, height, cholesterol and income and social data. So let's again run this new script. So here you can see that our social data is added here. This have 8 observation and 7 variable. So let's apply new command on this data. So if you want the summary of command, you can use summary. This is a command summary of social data. Likewise, I have changed the name. Let's run the command. So here you can see that the summary of social data, that is id, minimum, first, median, mean, quartile. Then you have gender, gender. Then you have age, that is age, weight, height, cholesterol and income. You will get a combined summary of all the variable data. So there is another command, that is Psych. So it is also another package. So you have to install this package. It is also used to describe your data. So let's go to tools, install packages, type here PSYCH. Let's check this. So this package is installed successfully. So let's activate the package library.pysch. Okay, the package is activated and the command is describe and in bracket, that is social data. Let's run the command. So here you can see that this is also one of the best command to describe your data. So these are variance, these are the n, mean, standard deviation, median, that is the trim, mat, minimum, maximum, range, skewness, cortices. So you get all the descriptive statistics here, and these are your variable. Likewise, you have command describe by social data, comma gender. So on the basis of gender, you will describe the whole data. So let's run again. So here you will see a beautiful command. So here your descriptive statistics. So here by this command describe by social, gender and data, you divide your whole data, bifurcate the data on the basis of gender. So you can see that these line divide the data. So these are the female group, these are the male group, and you will get all the descriptive statistics in a very structured way. So next command is you have, if you want some table, frequency table for your data, so you can run this command, that is attach empty car. So basically empty car is a default database that is already installed in your R package. It is by default. So you have to run command attach empty car. So let's run. So here you can see that the empty car is activated. So let's again type empty car and run. Here you can see the data. So this is the data, that is the empty car. These are the model of the car: Datsun, Hornet, Duster, Mercedes. So these are the car. These are the variable like mileage per second, cylinder, dispersion, horsepower, weight, virtuals, automatic, gear, carb. So these are the variable of your data. So let's use this data. So the another command is table, table in bracket am. So here you can see that in your data there is a variable am. So let's run this command. table AM. So here you will see that AM automatic or manual. A for automatic, M for manual. 0 that is 19 and 1 for 13 that is automatic, that is manual. Likewise, you have another command. If you want two dimension, that is one dimension, you have to write the command f table. So in between bracket you have am and second comma is vs. So let's run the command. Here you will see that f table. So you have am and vs, that is matrix basis. So 0 that is 00 for 12, 01 for 7, 10 for 6 and 11 for 7. Now we have another package, that is Stargazer. It is also very useful package. Let's go to install package Stargazer, Stargazer. Let's install this. Okay, its package successfully installed. So let's activate the package library in between bracket strgazer. Let's run the command. So here you can see that this new package is installed, and these are the author Vec Merrick 2022. So in that year, this is the package by the author, added by the author. So we activate the package. So in this command, this is the command stranger STAR stargazer, and in between bracket empty car. This is our data frame, comma type, bracket text, comma title. Title is, we give title equal to descriptive statistics, comma digit 1 and out equal to table dot text. So this is our command. So let's see how they arrange the data of for empty car. Let's run. So here you can see that this command is executing and we will get a structure, very structure descriptive statistics. That is the statistics. These are our variable, that is n, that is the mean of all, that is standard deviation of all, minimum of, maximum of all. And next command is if you want to flip the data, that is mean and statistic. If you want to flip the data, you have to use this same command stargazer, empty car, type text, title descriptive statistics, digit 1, out, table dot text format, and add, you have to add comma flip equal to true. So when you run this command, you can see that the descriptive statistic is flipped. So these are mean, standard deviation, median, and these are your variable. Now it is flip, change their position. Likewise, you have wonderful command, that is summary tool. So you have to type summary tool and then double dotted line. These are the command df summary, that is bmi, that is our old data. Let's run. So this is loading. So here you can see that these are the summary tool for bmi, df summary. So dimension 6 by 3, there is no duplicate. So this is our table. So age, that is numeric, mean, standard deviation, minimum, maximum, IQR, and these are the frequencies. These are the graph, valid and missing. No missing. So these are the graph. So again, you type summary tool double dotted df summary for empty car, because this is a small data, and empty car you have more variable. Let's run for this empty car again. So it is loading, wait for few seconds, and now you have your data. So here you can see that this is summary for empty car. So you will get a very structured descriptive statistics like mpg, cylinder, dispersion. These are the statistical mean, median, maximum. These are the frequency. These are graphs and values. So here you can see that there are, this is the type of histogram. For mpg you have histogram, some basic histogram, and for cylinder you have markup. Likewise here for dispersion you have histogram, for hp you have histogram, for weight and you have this histogram, and likewise you have vs, am and care you have markup. So this command is df summary. And again you have one more command, that is table.1. So you have to first install the package, go again to package, table1. So let's install, pack successfully, unpack. So let's again activate this by library table1. So here you can see that this activated, and the command is table1 double dotted table1. In between bracket you have tilde sign, age plus height plus weight, and then space and space. Then you have gender, on the gender comma data.bmi. So this is our data frame. Let's run this command, run. So here you can see that it will show you, let's close this, it will show you in a structured way. So the age, mean, median, height, age, mean, median, weight, age, median, like you have female, male and overall. So these are your, for female, these are for male, and overall you will get result. So the table1 command will give you a combine of these descriptive statistics in a proper way. So that's all for the descriptive statistic part in R programming. Thank you.